Welcome everyone to Symphonic Machines V1.0. We are here with Mümün, and we're going to be learning about Houdini and specifically his really awesome and unique Houdini work and how to kind of do some of the things that you have seen him doing with Houdini. Mümün is an Austrian architect, speculative artist, and a computer designer who works at the intersection of reality and virtuality. His work focuses on data-driven design, experimental spatial processes, and the integration of media into architectural expression, creating unique experiences and innovative forms. He holds a master's degree from the University of Innsbruck and currently works as a computer designer at UN Studio in Amsterdam. Keser also works freelance as a designer, educator, and artist, and has led workshops for institutions such as IAC, Bartlett, P Academy, University of Innsbruck, and others. So, welcome, Mümün. We're very happy to have you here today.
Happy to be here as well. Thanks for the invitation. And I'm
Yeah.
also super excited because I'm gonna show something that I really enjoyed doing. And yeah, I hope it comes well or people receive it well. And besides that, from my end, I don't really have any more to add what Mike has already said about me. So I think people who might know my works, I like to question things in design workflows. So I try always something different than what's known. And yeah, today I'm going to show one of these multi-layered design workflows that mainly uses the rigging system within Houdini in order to create some very machinic architectural stuff. But yeah, it's basically it. Do you have anything more to add, Mike?
No, that's it. We can get started.
Yeah.
If you want to share your screen, and yeah.
Okay, let me share my screen real quick. So please let me know if anything is blocked or not.
Looks good.
Okay, awesome. So on the right bottom side, you will see also my keystroke. So
Yeah,
if
we
you,
see it.
sorry, that's good. All right. So today, well, yeah, as I mentioned, like it will be machinic, it will be robotic. So we will try to mimic something that we see every day, especially if you're in an experimental design field, like this robotic design and so on. But mostly it is used to print things. But what happens when we actually use robots as architectural elements as well? So that was mainly the focus that I set myself in. And yeah, let me just quickly show you a sneak peek. I think you guys already see some of the imagery that we posted as marketing for this webinar. And like this will be the end product of today's workshop, like having having a really responsive kind of stairs. And I will also show how to make it responsive as well. So yeah, this will be the hopefully the outcome if nothing crashes, if everything went well. But yeah, I'm optimistic about it. So I would say let's get started since we don't have that much time. Like I know for 4 hours sounds quite promising or time-wise quite good, but it might be like with workflows like this, uh, it might get a little bit longer than that. So I hope you didn't plan anything other than this today because we might have some overtime. But I will try my best to keep it on time. Anyways, let's open up Houdini. Before we start everything, I also prepared a Drive folder. So I'm gonna share a link in the chat. So please open that link. There you will find resources and also the workshop files that I will save on each break. So when you when something happens, when you can't come along with time, I will save the file there. So after the break, you can just pick the whole workshop up from there. But mainly as a tip that I can give you guys is don't be anxious about if you don't understand anything right away and or if you can't tag along with the workflow, don't be like anxious about it because the main focus for you guys today is to understand what I'm doing, understand why I'm using which node where, because you can always rewatch it or rebuild the script anyways. The main thing is you understand the workflow and how I think or how I build the thing. So that's the key thing. Because most of the time, people that watch tutorials or courses like these, they are really they really want to tag along with the instructor, and that way they don't pick up every information that they receive. And in the end of the day, when they open the file the next couple of days, they forgot almost everything. So just try to understand what I'm saying, try to get why I'm using what where, and you will receive the files anyways. And also this is recorded, you can rewatch it at any time. So um, don't be stressed if you don't tag along. So, all right, let me just share real quickly the link so you have also access to that folder. So you can find it in the chat. But yeah, I think we have got everything now. So I would say let's get started. So this workflow mainly focuses on like how machinic elements function, especially robotic arms. So what I try to do is I try to do an abstract representation of a robotic arm, because if you guys all know how it functions, if you know what I mean, like let me just open real quick something to sketch on. If it opens, yeah. So a robotic arm has axes that only rotate to one axis. So what I tried to do is I created like these arms, and it has like, let me just sketch it this way. I create like this kind of line system, and I separate this system into 4 segments, 2 arms, and 2 connectors. So let me just quickly sketch it. And as you can see here, I have like this small bit, and each small bit for me was like a rotation axis. So this axis rotate this way, this axis rotate vertically, this one rotates this way, also horizontal to X, for example, and this one also vertical. So I only set constraints there, and this is my end piece. So if I move this point, then based on this constraint, it will have like some really robotic motion. But this kind of idea is like coming from an industrial robot, where industrial robot has axes that has, for example, one for X, one for Z, one for Y, and then a couple, like it's mostly 6 axes that enables the robot to move in any kind of direction, 360. So what we do for this kind of setup is, first of all, we start really methodical. So we try to do something, we start simple and build on top of that with time. So let me adjust the scene. So let's collapse this parameter editor. So I need more space here. And let's press P to get the parameter editor here. And let's create a geometry network. And let's call it let's call it the machine. And double click and jump inside. So I will try to explain also some beginner related stuff, but I will recommend also if you are not familiar with Houdini, I would recommend before watching this, also checking out some beginner stuff as well. Yeah, the folders are currently empty, especially the workshop folder, because I'm gonna save the file there. I don't wanna share the file immediately. So I would just make sure that also that part of the workshop is very interactive. So you will receive the file after the break or before the break. So the folders are empty currently. Only I think the resources folder, you have like this obj1 obj file. You can, if you want, you can download it, but we don't need it yet. I will let you know when we will use that. But yeah, anyways, so I would say let's get started. So as a start, what I like to do is I like to create a box, a super simple box. And let me also change the visualization here. And I'm also going to set this one to the background. So if you press D, you can open the display options. And on the background tab, you can change the color scheme to dark if you want. So here, I want to change the box size a tiny bit. Since it's 1 by 1 by 1, I want to have a little bit bigger kind of scale. So let's set it to 15, 10, and also 15, 15, and I think somewhat like 75. So it's like this long box. And let's change the axis division to 2, and here on this axis to 3, or yeah, 3. So we have like this type of segmentation. Here I will use the lines to recreate the sketch that I made here. Normally I use Vex to do these lines, but since we don't have that much time, I will probably share that script as well for you, so you guys have some control over that as well. But for the sake of this workshop, we will do it in a simpler way. So normally, if I can show you how it is. So normally I set up the lines like this, like it's the same thing. It is already divided. And here you can see con arm, arm one, arm two, con arm one, con arm two. And here I had like this script that helps me to define which direction they look or how much the offsets here are. Just need to make it do it again. So here you can change the angle of this arm or the sizes of each side. But yeah, I'm gonna share that with you, this script with you guys also. But before that, let's build up the simpler version. So for the simple version, what I like to do is mostly I get this box, and then first of all, I use ends node to separate the geometry a tiny bit, or separate the primitives and open them up. For now, each side is closed, so just go to close U and set to unroll with no points, and it will extract the edge lines. Then let's check the info box. Now we have like 22 points and 10 primitives, which means it kind of created now a line work that each face is separated, and we have a lot of double lines or overlaying points and lines. What I want is a much more cleaner line work, so I only want one line here, not two or 3 lines. So let's use fuse first. So let's fuse the points that are, or snap the points that are close to each other. So this will already reduce the point number from 20 to 12, but we still have 10 primitives and 50 vertices. And just to make sure that everything is a line, I will convert this also to a line, convert line node. And now we should have 12 points, primitives are 20. Now it also separated each segment, and vertices are 40. And this sounds about right. So now you can use also, if you want it, you can use carve to make sure that, like, if I do, for example, a blast now, I think now it should be fine. Sometimes, like, you need to be able to select only one curve at a time, and it looks about right. And I use sometimes also only carve to blow up the geometry as well, or blow up each edge from a polyline as well. So just to make sure that it does, just go to first view and second view, activate both, go 1 and 1, and then breakpoints, activate that, and cut at all internal view breakpoints, which means it will cut the geometry on each edge point or kink. So just to be sure. All right. Now, what we do is we will now create like this four elements of our system. So the 2 arms and 2 connectors. So for that, let's create a blast node and then go to group parameter, go to this icon, press it, and now we can select the edges that we want. So here I will just select this one, and this one. So these 3. Let's enable delete non-selected. So only the selected area is visible and rest is blasted. Then I will create a group name. And let's call it arm1. And it can stay as a primitive, and we don't have to select any base group, so it will immediately create a group with 3 polylines. But now what I want to do is I want to actually fuse this together. So I want to have a connected element. So after fuse sometimes doesn't work right away. We still have 3 primitives. After fuse, you can also use convert line to connect the path. So in convert line, just go to connect path and enable it. And you will immediately have only 1 primitive and 4 points. This is important because in the previous one, in the normal one, we have 6 points and 3 primitives, like 1, 2, 3, and each endpoint of these 3 primitives means 6 points. That's a little bit too much. If you want to have this system and also these 4 elements, the elements need to be connected properly. If not, we have like overlaying points and unconnected pieces. So when we start rigging it, it will start flying. You will see flying elements all over the place. So now with this, the first setup is done. So this is our arm1. You can also create a null by the end of it. And you can also press Shift S to have a much more discrete line work, or a much more proper line work. The other one is a little bit too messy. And let's call it out arm1. Then we can copy this. Let's go to blast, go to selection again. Now I will select only this line. This is only singular line, so to be honest, we don't need this part, but just to be sure that I have this here, because in the future I also may have 2 lines here. So you can experiment with this line work that you said. You can experiment different type of combinations. So you don't have to do it like me, like how I'm doing it now. So you also have the freedom to do it in your own. So the selection can change for each one of you guys. But for the sake of the workshop, I would, trust me, it would be nice to use also the parameters that I'm using now. But we will get to that point soon, why I recommend that. So here we have the first connectors. So let's call it con1. And let's copy both of these. And here, the third one, I want to select this time this, and this. And for the last one, select this. So let's merge all of these together. And in the end, we have something like this. And of course, we can also color these out. So we can add also color nodes for each of them. Let's make this one red. Let's also rename it properly. This is arm2 and arm2. Oh, no, it's already did it automatically. Nice. Then let's make this one yellow. The other connector as well. This one can be, let's make it blue. All right. So we have our network, or we have our line work. Let's call this one. Let's make another null in between. And let's call this one out machine or out skeleton. This will be our skeleton. So the whole rig will use these lines and the points of these lines to identify where are the joints, and also we can add constraints based on the point number. So the system can affect knows in which axis each of these joints should rotate. All right, so you might, if you want, we don't have really any extra attributes here, but in my personal setup, I have also some normals and so on. What you want most of the time is you also want to have a clean geometry with no extra attributes. So I would recommend doing an attribute delete after the skeleton. But yeah, it's optional. You don't have to do it. I will just put it in there just to have it. And let's flag it or bypass it. So yeah, all good. So for the skeleton, we have now a skeleton network with 12 points, 4 primitives, and 12 vertices, which means normally we should have actually 9 points. I want to have 9 points, which means I don't want to have overlaying or duplicated points on each intersection point from each segment. So here I will use only a fuse to get rid of those extra points. So now we are setting up properly the skeleton. So I want to use fuse. As you can see now, it's fuse because now the color gradient does have a gradient, which is also quite nice. And we have 8 points and 4 primitives. Even though we have 4 primitives, the points, we don't have any duplicated points. And you can also check that out by visualizing the point numbers on this icon here. So start is 0, 1, 2, 3, 4, 5, 6, 7. All right. Now, what we need is a skeleton node. So with this node, what we can do now is, I don't know why, it gives me always this error, but here, if you select skeleton, you don't see anything because we don't really write anything in there yet. Normally, you can select the skeleton, press on this, and then you can do also your own line work by activating the handle. But since we already have line work here, what you can do also in skeleton is you can stash the input. I don't know what's wrong with the stash. Let's create another skeleton. So, this is strange. Yeah, that's super strange. Normally it should work. Oh, let's say KineFX. This is the KineFX problem. That's funny. This is also something that happens sometimes when you have what's it called? They update the Houdini all the time. I'm using Steam for my license, so it updates it automatically all the time. And some nodes have some issues every now and then. Like I have it, for example, here. It's already in there. But this one that I created now doesn't work. That's something. That's a little bit tricky. I think they changed some stuff in the main code. Yeah, what's not working? The Python script is not working. Does it say? Yeah. Anyways, you will have the file here. In this file, it works. So you will have the node that works. It's kind of funny why it doesn't work now. But I think you can also use WEBPAGE to generate the name. Because what this skeleton does is it actually generates this local transform name, scale inheritance, and transform. So it kind of stashes the geometry that I feed in as a rig. And then I can use the name, for example, like here, to really start doing some stuff with it. But now it has some apparently issues. But yeah, now this one I will share the file. You know what? I'm gonna save this file immediately so you have it. So you can download it and carry on from here. It's quite odd. You have access to this file, so you can open it and carry on from here. So the skeleton, I hope, does everyone have the same error? Or is it only me? Okay, David has it too. It's quite odd. I don't know why. Yeah, yeah, I think it's a Houdini version error. Yeah, what a timing we have, huh? It literally worked yesterday. Yeah, it's always like I'm also having a lot of issues with the with redshift and also rendering stuff. Like it just crashes very arbitrarily. Like it doesn't make sense sometimes why it crashes. But yeah, they really need a proper update to fix all of these problems. And one of them is this, apparently. This is a error that I never had. And I even opened the file and created the skeleton like 10 times or changed it 10 times, never popped the error. And now during a workshop. But anyways, Now it should work for you guys as well. But yeah, the main thing is we just need a okay. That's a bit odd. Let's try it. Okay, now it works. We don't need fuse apparently. But the issue is, as you can see, without fuse, let's try without fuse. So it doesn't give any it doesn't give any errors, but without fuse, the issue is the overlapping points. So it jumps also around. And let's try instead of fuse convert line. Oops. Yeah, it still doesn't do. Yeah, the thing is, I want to have a structure like this. It starts with 0 and ends with 8. So normally it should work. It was working all the time. So the fuse might be struggling to determine which points should be shared across different primitive types. Yeah, it's normal. It kind of forces them to go, but maybe after the fuse we need a convert line, like we did earlier. Maybe that's the key. No, it doesn't like that. No. Yeah. Anyways, this is something that, or I know what I did normally with the other setup. I also used add node, deleted the geometry, fused it, and then created an add node again to make a line. And you can also make it closed and then use this as the skeleton. Does it work? No. Add, what did I actually add? One more thing, add, and yeah, this is the workflow that I did previously. So quick fix, I got it now. It doesn't give any errors. So create an add node. So open up the whole thing. Go to points, delete geometry, but keep the points. Then you can fuse them while they are points. So you don't have any overlapping points. Then create another add, but this time go to the second tab, go to by group, and enable closed. Then you will have like this one primitive that kind of covers all of the points or connects all of the points as a primitive. And then use ands to open the whole thing up. So unroll with no new points. Then you will have like this closed line. And then we can generate the skeleton with this 8 or 9 points. So this should work. You either use the right one. As you can see, it's super simple. I don't know why it's giving the error. Normally it works, but I think this convert line to fuse makes in the end of the day sense because we have like this overlapping points and it doesn't know which point it can use to how should I say which point should be deleted and which point should be used, and then it kind of gives this skeleton some sort of brain damage. But yeah, thanks Benjamin for tagging this up. But yeah, here is the quick fixed thingy. Let me save it again. So this will update the file in the drive as well. All right. So now what we want to have is we have now all of this information for local transform, name, scale inheritance, transform, and so on and so forth. What I also like to add here is a node called rig doctor, because here we can do something which is important for the rig system, and it's here it also does this whole thing like initialize missing names, point, so you can add a prefix. Here we set point, but we can also say something else. But for now, it's good enough. And this will also debug any kind of hierarchy that we are having, and also you can output different kind of indices and so on. But what I want to also get is this initialize transforms. So these transform nodes or extra stuff that we have here actually are stored as a matrix inside, or as an array inside our geometry. And yeah, the name of each point. This is also important. So this is our rig setup. Let's call it out. No, null. Let's create a null and call it out rig. And yeah, so now what we can do is we can now select the point that we want to use as a driver to change the geometry. And then we can add this change into the system in a rig or in an I key. And then with that, only with that one point, we can then start moving the whole kind of machine, or all the arms and the connectors. So for that, what we need is, so first of all, we will use in the end this full body I key. So this one. So this node needs two inputs. One is the required target skeleton. So our target skeleton is our main skeleton. So it comes directly from the rig doctor. And then the target source skeleton is the one that we change. And the thing is, we don't have to change the whole skeleton. We can only change, for example, only one point. And since we have the name, the target skeleton immediately knows which point of this skeleton it will deform, because we only deform one point and in the space, and it immediately knows to deform that point. So now let's see how we can do this. So let's create a group, or yeah. Sometimes I do it directly with a blast, but I will call this one target. And here I will select 0.8. So this will be my last point, and also change the group type to points. And as you can see, it highlights immediately that point. Then what I will do is I will go and blast the whole geometry up, delete non-selected, and select target. So we only have the point here. Then you can create an add node, add, and we can create a point in space somewhere around, and in this case it's in the middle. Let me just show you. Here is the point. Now I can move this point around and so on and so forth. And what I want to do is, since this point that I blasted out from the whole rig, this point inherits all of the attributes that we need from local transform, scale inheritance, but most importantly, the name. So we can use now, or we can use attribute copy to copy all of the attributes that this 0.8 pass to the add point or to our point that we created. So here, we just need to change the attribute name to name. So I want name. Only name is important in this case. Rest is fine. Rest will adjust it anyways because this is our source. So now I can use this as the second input. And in full body IK, we need to make sure that this node is using a mapping matched by the attribute, and in this case by name. So as you can see, that's why only using name is enough to copy to point, and then if we change this point now, the whole rig will respond to that. Now we have an issue. And the issue is now it just forces the point, forces the geometry towards that point. And we have like it kind of looks nice, but it's not there yet because we don't have the actual look that we want to have, like a robot. Like all of these needs now the constraints that we want to set. So it only rotates to get to that point. So it rotates all 4 axes to get to a certain point. And that way we can mimic the robotic movement. This is much more like a stretched movement and it's attached. Also, you can use this kind of logic for any type of thing that you want to build. But what we want is we want to add some constraints to our rig to say, hey, look, I want these 2 points to rotate only on X axis, for example, and this one only in Y axis. So that's quite straightforward to do. For that, we just need configure joints nodes. So we've configured joints. What we can do is, you know what, I'm gonna activate this attribute delete and delete the colors. Those are fine, but yeah, with time. And let's go to skeleton and stash input. Yeah, this is much nicer and it's all white. Okay, under configure joints, now I want to define the axes in order to have a saying what each joint should do for the sake of the movement. So for the first configure joints, let's call this rotate only on, like, I wanna tackle this joint first, 2 joints, and this is on my x-axis, so rotate only on x, rotate only x. So here, you just need a configuration. Let's set it to 1. And under here, you can then now start saying like rotation rate is on x-axis 1. So this means all the rest should be 0 normally, but since this is a rig, we also need some tolerances. So I would set it to 0.0001. The same goes also with Z, 0.001. And the transformation, instead of setting this all to 0, 0 is mostly like you will see like this glitching in this kind of setups. And this glitching sometimes comes also with this hard numbers. You need some tolerances in between to damp the whole thing. It's like a real life robotics or real life machining stuff. Like there is always this tiny bit of a tolerance you have to leave or enable to it to move. If not, it will start to break, something like that. So I will put everywhere except this x-axis on rotation rate 1. So everywhere else should be 0.0001, 3 zeros and 1. And then I will go to limits. And on the X angle range, I will just set it to, here you can also set a certain limit. So after a certain angle, it stops. But I don't want to have limits. I don't like limits. No boundaries accepted here. I'm just kidding. So let's set it to minus 360 to 360. Actually, you can also set it to minus 180 to 180 or 0 to 360. It doesn't matter. So this enables you to actually rotate in both directions 360. But yeah, this is the configuration setup, but we also have to select the groups. So we have to say which axis I mean rotate only. So here I can set 0 and 1. And now use only the point 0. Like you don't see the 0 here, but it's right underneath the point 8. So it's the starting point here. And point 1. Then we need the second one. The second one is rotation only on y-axis. So we change the whole thing. First of all, I will set it to 2 and 3. Let's change the name 2 and 3. And this should be 0 0.001, 0001. And this should be 1. And here I will change this y angle range to minus 360 to 360. Then I can copy it again, or I can copy both because the other two are the same, 4 and 5, 6 and 7. Don't come with the meme 6, 7. You might wanna, we will say it often today, but no pun intended. Okay, here the axes are 4, 5. I can do also every point in here, but I would be really cautious with that. I like to structure, I always like to structure it step by step instead of doing it fully in one joint. But you can also add like configurations, many configurations in one node as well. But yeah, I just like to do it this way so it is a little bit more structured. So it doesn't matter. So you can do all of these configuration in one node as well by just adding one more extra, and so on and so forth. But yeah, I just wanted to have each of these configuration out for the sake of what's it called? For the sake of the system or whatever. Okay, 4, 5, and then 6, 7 as the last one. All right, now we configured so we defined the configurations, and now let's see the full body I key. And now you can see like this angle of each arm never changes. So it always stays as it should be. So when we use the lines to generate a geometry as a skin for this rig, we never have intersection issues because this kind of line work never change because we set like as the rig configuration already we set up a rule that it never rotates to other direction and it also never has a transformation in any kind of direction. So if I now, let's go to the handle, if I now move this point, it moves around with it as well, but we have an issue, the whole line moves. What we want is this starting point to be actually, needs to be fixed. And this can be done pretty easily. You just have to enable the pin root. So it stays always in the starting point, 0. It doesn't move anywhere. And other things also I would recommend doing is I would also do compute local transform, activate that. And under configure, you can also set a configuration for that as well. Or also, yeah, here, not on the center of mass, but on the configure, just add one configuration. What I want to add is here, the point 8 is the point that I want to put the maximum weight on, and the priority, I set it to 1. And then, yeah, besides this, I think we are all set. And Another thing what I also like to do is I don't like tolerances here. Let's set it to 0, but I want to have damping. So with minimal damping, as you can see, it flies around because the configurations are set so strictly. Sometimes it will just start moving in small bit of failure. So we want to damp this to have it should still follow it, but with a certain level of damping. And iterations, let's set it to 1000, so we have a proper iteration process. So now you just have to be sure or make sure it's like a real life robot. Like if you guys are familiar with using industrial robots, there are certain boundaries the robot can't cross. Like it always gives errors because it knows if it goes that way, it will intersect with the other arm, or it will have some self collisions, or some sort of the axis has some configurations that it can't actually rotate 360. So that's some stuff that you can also have to consider in this kind of setup, because since it's so strict, sometimes it jumps only, like here, for example, it jumps only because it can't go further than this. The length of this arm is important, and also the other, like also the distances in between joints, because it knows if it goes further than this, then it has to go beyond the configurations that we set. But, but this setup always wants to meet the configuration, which is quite nice. So you can actually build like with experimentation, you can start building a system that would also work in real time when you actually 3D print or build it. Because you know, hey, look, I got no issues moving around. There is no glitches, which means if you want to run this model in real life and make the movement similar, you won't have any issue with intersections and so on. So with this way, you can really recreate something that can also have some real life application setup. But yeah, as you can see, for example, it also makes sense. We don't have any rotation towards the z-axis. That's also funny. I left that out, but you can also add something when you try this. You can also add all three axes. Because if I move, for example, in this direction towards x, which means the whole thing needs to normally rotate in z-axis at some point, but it can't. So it glitches a lot. But yeah, this is for now basically the whole setup. So you can also start animating this, for example. Like let's say I want to move from here. Let's go to first frame. Let's go to point, press Alt, hold it, press the parameter. It will turn green, which means we set a key, and go to, for example, 120. And let's change the point. Let's bring it up here. Press Alt, hold it, point. And now we have an animated ring. But this is a super simple setup based on this whole idea. Of course, there are other applications that you can do as well. You can also rotate only on one axis. But yeah, for example, we can also use rig pose instead of using this. And under rig pose, you can select, for example, transformation. I want to set, that's the problem here. Group here. Let's set 0 and 1. You can also do, for example, here I set X, and let's move this here. And you can also use like this rig pose to actually transform it. Let's add another transform, and let's say 4, 5. Let's delete this part. And let's rotate this one on. This one was on y-axis, right? Yeah. And you can also start manipulating only on x-axis. So you can start doing that also. But yeah, I think this way it's much better because it makes sense that the tip of the whole thing actually drives the whole thing, which means in real life you can just use the tip to follow certain kind of flows. And this is something that we want to do now. So instead of having a point that we move based on x, y, and z, what happens when this point follows actually another geometry? And then we can make it attracted to a third entity. But yeah, before doing that, this is the main rig setup where you can generate the line, where you can define the skeleton, and then based on some configurations, you can start modifying it. Any questions, Antonell? Are you guys tagging along? I know we had a tiny bit of an issue with the skeleton here, but I think this quick fix should. Yes, I'm gonna save this now as setup rig. So there should be a new file with the name setup rig. Yeah, of course. So attribute copy, what this does is, so here we have our rig, right? Here I just wanna define which point of the rig I wanna, it's fine. Again, Jakub, you don't have to really do the things that I'm doing immediately. Just try to tag along and try to understand. And if you have any questions about the certain kind of bits of the workflow, just reach out. And yeah, about attribute copy. So if you have the rig set, like the skeleton set, and you want to say, okay, from this skeleton, I want to move a certain point, or I want to use a certain point to have it as the main instigator of movement, then you can just pick that point. Like, for example, in this case, I picked the last point, the point 8. I excluded it or I deleted all of the rest. And here, I set a reference point. So this point with add, let me actually go to geometry and make this point bigger. Yeah. Do you guys see the point better? Let me get rid of this. Yeah. So I have the point here. This is my last point of the rig. And then I select it. I deleted all of the other points because even though I deleted all of the other points, I still have the attributes of this point. You will see it, Hannah, soon. Then I use then this reference point that I set in the space somewhere to copy the attributes from the selected points from the rig to the reference point. So all of the attributes that I need to move the whole rig are now stored in the reference point that I generated, which is flying around in the space. So then when I put it as a source skeleton into full body I key, then the target skeleton immediately snaps to that point because it knows, okay, that's my source skeleton. So let's then the target skeleton adjust itself based on the position of point 8 there. And that's why I also set the configuration here as to really give a weight to, because I want this point 8 to be the main driver of the whole movement. It's like when you see an industrial robot, you actually program the tooltip, the movement of the tooltip of the robot, and that kind of defines how the rest of the robotic arms should move in space. So yeah, that's basically it. Does it make sense? I hope it makes sense. And yeah, Yes, I personally never tried it. So I also used Unity to control robots, but mainly back then when I used it, I used Grasshopper to do it. But it's definitely, I think, over Python connectivity, you can definitely create some sort of a connection with robotic I/O. It should be possible. But it's not. It would be nice. Yeah, I would definitely like to tag into those areas, or I actually want to build these things. So yeah, it's possible. And yeah, Hannah, you see the line that we generated, right? This one. The driver OBJ is the skin for this one that I created. So in the next chapter, or in the next session, you will see how I will give some glimpses how I did it, but that's actually the geometry that corresponds to this line work. You will see it soon. All right, I saved the file, so you should have it now. And yeah, next, let's take a break for around 9 minutes until 17:20. 17:20, like 9 to 8 minutes. And after that, I will show you how to make actually this rig attracted to another object, and also how we can use the driver OBJ to actually have a geometry all around the line work. But yeah, all right. See you soon. So welcome back, guys. I hope everyone's here. All right. So we have got now our rig set up. And now thanks, Walter. Really appreciate it. Now what we want to do is we actually want to control this rig based on another geometry where we let a point move around that geometry and make this thing move according to that. So for that, what I want to have is like one of the, like, for example, we just need to replace this add node. So this point that we actually use to move this tip around. We want to use now another geometry to extract a moving point on top of that to make this robot follow that path. So for that, what we need is, I like to use a circle here for a start, but this can be any type of line, to be honest, or any type of line work. And let's set up certain things for this circle. First of all, it should be on Y and Z plane. So it needs to be perpendicular towards my first exit. I want to start off with that. Instead of changing the radius, let's set the uniform scale to something like 80. And I also don't want to have like this kinks. So let's add some divisions, like 50 should be enough. Then the center, I just want to, or before going towards the center, let's change the arc angles to 180 and 0. And I don't want to have an arc type closed. I want to open arc. So we have like a half arc that kind of surrounds. Let's go to the node and open the template. So we still see the rig. So let's position this also somewhere it's suited. It has some intersections here. Let's say 20. The center on y-axis 20, and the z-axis, let's also shift it towards this direction a tiny bit. And let's add some rotation. Let's make it a little bit interesting. So let's rotate it like this. So I think as a setup, this looks nice. I want to have another control. So I don't want to use the whole arc. I still want to use only a section of it. So you can use a carve node here now to actually carve out the flow based on first view and second view. So you can change the size here as well. So I want to just set the second view to something like 0.995 and the first view around 0.5, so half of it. So this will be my moving range. Then what I want is just to make sure that this path works. I just add a convert line to convert line to make sure that the path is connected, and it also generates this rest length, which means the length of the arc. So here, if you go to geometry spreadsheet, you see all of the attributes in numbers. So the first one are points. We need to check the primitives, and here you can check out the rest length. I'm gonna change this number. It should also change. So this kind of represents the length of the line. Not kind of, it's represents it. Anyways, let's go ahead and do, I can now use another thing called carve. So we can use carve again, but this time, instead of instead of deleting some stuff, I just want to extract the point. So it's quite easy. You can just go to extract, and extract points. So it extracts only the point. So what I can use now is, as you can see, an input is only 1 point. I can use this actually to drive the geometry. So when I change this number, as you can see, our rig follows exactly that. Then what I want is I actually, instead of using here the slider, what you can also use is an attribute, which means if I write an attribute that uses a certain kind of value or data to define or to link the length of the arc with the distance towards another object, which means if it's close, then this value will be also very low. And if it's far away, then this will be also high. So which means as something approaches our machine, the thing can open itself up. And if it's far away, it can close itself. So it's kind of like this interactive setups where facade elements or stairs all of a sudden appear when you approach it. This was the main idea of the whole thing. So we can make actually this whole setup reactive towards the geometry. So let's actually generate now this attribute. And this attribute is should be a detail attribute, or it should be a primitive attribute that contains only one value, and it should be between 0 and 1. But yeah, let me just show you how we can achieve that. So for that, first of all, we need an attraction source. So let's create a sphere. And by the way, this can be any type of geometry. So let's make the sphere quite big. Let me disable the display. And yeah, we can also make a transform after this. Let's translate this. So we can translate this as we want. And based on the distance in between these two thingies, based on the distance from this to this point or to this arc, we can then start to position the point of the arc in various stages. So what we want to do now is I want to calculate the distance between the arc and the sphere. And this can be done either with distance from geometry, but what I like to use here is the vex option of it. So you can create a wrangle, and the first input will be our arc, or the arc segment, and the second input will be our sphere. And yeah, don't mind the warning. I will get a warning because I set up a preset, so I have to delete it. And here, if you go to this icon, the arrow, and open this up, you can select nearest point distance. Here you can see some presets that comes with Houdini. So you can also check out these presets. There are some nice helpful ones, but the most nice one is the nearest point distance. It's happy to calculate the distance immediately. So if I open the geometry spreadsheet and go to points, you will have like this. From each point of arc, it calculates the distance towards the sphere. And as you can see, it's everywhere different, which makes sense because our arc has actually many different points, and each point has a different distance. But what we want to do is we want to have one distance value for the whole thing. It's quite easy to do it actually. First of all, I want to change this point attribute to a primitive attribute, because for the carve attribute we need a primitive attribute. So we can promote this. So we can also promote attributes to other entities. Like for now, the original class is point. The new class can be primitive. Let's connect this with the Wrangle. And by the way, in Vex, what you also have is you can also set your own presets. Like if I can show you my presets real quick, I have got a lot of presets already set that came from the last year's stuff. And as you can see, I can, for example, use the extend curve thing. And this helps me to extend the curve on the ends. And this is something that I can reuse every time. And it also generates automatically the parameters that I set back then. So you can also, if you calculate the density, here are some crazy stuff. For example, point attraction to attractors, or what was it? N-based line growth, for example. I don't have any normals, but let's create an attribute noise with some normals. No, this is actually for a growth. I need the benching. Yeah, the basic line growth for benching lines. And this kind of generates this branching effect. But yeah, with only a quick tip, you can also set presets in Houdini as well. Just go to legacy presets and SideFX presets. So if you have created a Vex code and it's something that you wanna use in other stuff, or you wanna save it in your Houdini system, you can just save it as a preset. Exactly. It's like a custom script that is stored in the Wrangle environment. Anyways, back to our main goal. So I want to promote the point distance attribute to point primitive distance attribute. So let's create the attribute promote. Here I have to define the name, it's distant. Original class was point. I want to have the new class as primitive. And you can leave it as average. And this already gives me a primitive attribute with a certain distance value. But the thing is, let's also animate the sphere first. Let's sphere, let's say it moves from here. Yeah. Comes from 300 and comes down to, I'm going to change the time to 120. And let's come down to 40. And now, if we go to attribute promote and look at the geometry spreadsheet, this changes with frame, which makes sense. I get the distance for the whole primitive, and it's actually working. But what I want to have is, I want to actually calculate the maximum distance that I will have and the minimum distance. And minimum distance can be 0. It's always set, but the maximum distance, I just want to have the access to the maximum available distance. So how far is the object, or how far the object will be? Because since now the animation is very linear, it comes far and comes from far to close. But what if it's also moving around very randomly? So the distance will change. So if I would do it based on the start and end frame, it is linear. It won't work. I just need to, first of all, get the whole range of motion and whole range of distance values, and then remap the values between 0 and 1. I hope it makes sense, but I will explain it even further. What I want to do now is I want to trade the whole movement of this sphere, or the whole movement of the sphere in relation with the line. So with trail, I can actually preserve original. Trail length, I will set it to $f end, which means it will always automatically picks the maximum amount of frame. So here my range is between 1 and 20. So this trail length will be 120. So it will always be set to that. And as you can see now, I duplicated each primitive with the amount of 120. So I have now, actually we see only one here maybe, but those are duplicates. So I have actually 120, all of them laid out. It doesn't matter because in the end of the day, we won't use these duplicates. We only want to use the distance attribute of it to calculate the maximum, to get the maximum distance value. And this is easy to get. What we need is an attribute promotion again. So attribute promote. Out of all of this bundle of primitives, I want to get the distance. So original class is primitive. I want to get the distance. And the new class, I want to store it into a detail attribute. And here onto the in the promotion method, I just want to change it to maximum. So it will select the maximum amount. So now if I go here, you won't see the primitive distance value anymore or attribute anymore. It is stored in the detail. So it means it's only one attribute for the whole geometry tag. And it is the maximum amount of the distance. So if I now change this even further, this will always change with it. So I think I just need to go to the first one. Let's go even further and see now the distance is around 500 units. Now I can transform the attribute transform. So I don't want to, again, here we have like now 120 primitives. So I want to use my original primitive only. So this will be my first. So I want to transform the attribute. And I will also call it, change the name, I don't want to use the distance. I want to use the new one. It's called max. Let's call it max D for maximum distance. And here on the attribute transfer, let's activate only the detail and let's call it max D. And you can also go here, original, so we still have the maximum, we still have distance. So we can also copy this distance and transfer this distance as well. Now, the only thing left is we want to remap the whole thing now. For now, we have all of this set. So we have our maximum distance detail value, but also our distance values per frame. So what I want is I want to change this distance primitive value based on the maximum and maximum range, and bring it tone it down to 0 and 1. So let's create a wrangle. This is only 2 lines of code. So at first, I want to create a variable called float, variable, and let's call it max distance equals to. And here I can use the detail function. So detail, and my first input is this one. So the geometry handle is 0. First thing, then comma 0, comma the name of the attribute that I want to use, and it's max B. So with this, I bring in the detail max value into wrangle, and now I can use a fit function to actually remap the whole range. So I want to remap the so the distance attribute and add this equals to fit, open brackets. The first thing is, again, here I have to define what values I want to remap, and the values that are stored inside this I want to remap. So add this as the first thing, add this comma. Then the minimum value, we can also get the minimum values, but you can also set it to 0. Then I want to have the max distance as my end bit of the source. The max distance as the maximum input. And then you can now define the range. So 0.0 and 1.0. You don't have to put 0.0, but for the sake of don't have to deal with any problems, I always add comma. Now, if you go to geometry spreadsheet, we have an issue because this distance is set inside point. We have to change it to primitives. So on the primitives, now as you can see, the distance is remapped between 0 and 1. So the maximum available position, we have a distance value of 1, and the minimum is normally 0. But since we don't actually go to 0 with our distance, this will always leave some room. But again, here we can also create another value called, let's make it properly, before maximum. Let's make another attribute promote, bring it to a minimum, and let's change the name to minb. And we will also have here on the detail, deleted something. Yeah, here. Now we have a maximum distance and minimum distance. And we can, here, on the attribute transfer, we can also add minb, maxd, and minb. It sounds like twin names. And now inside Wrangle, I can just add this float variable as well as minimum distance. And use the minb as the input source. And then this minimum distance can also define the minimum value. So which means when I go now here and go to the primitive attribute class, so the minimum distance will produce 0 and maximum 1. But sometimes I think now we have some sort of an issue here. Typo. Not really. But yeah, I personally don't recommend doing this because as you see now, it has sometimes doesn't like to, how to say, it has a moving minimum distance. But yeah, change the name. Yeah, it's exactly the same thing. But yeah, you can leave that out. For the sake of the whole thing, it is much more realistic to actually remap it between 0 and maximum distance and not minimum and maximum. Anyways, now we have our distant primitive attribute. So you can just connect this with the curve. And on the curve now, we can, instead of using the constant value, we can use attribute. And on the attribute, we can use distance. And now, let's open this up. Based on the movement of the sphere, the position of the point that drives our whole thing will change. Let's visualize this properly. Let's go to full body IP. And let's go to sphere. Let's open the, yes, can be. Yeah, this way you can actually link the TCP with this. But yeah, as you can see now, this sphere kind of can be the, how to say, driving force for the whole thing, and it attracts to it in any kind of means. So if you want to have like some sort of interactive setup, you can use this. Let me change the, yeah, should work. All right. So this can be any kind of sphere. The movement can be any type. The main thing is this setup allows you to really the flexibility with experiment with different type of movements and connections. All right. It's getting dark. At some point, I have to switch on the lights. Anyways, let's also see how we can link now this geometry with a skin. So we actually have a geometry that kind of wraps around our ray. So since we have like this very neat line setup, we can actually model something according to these lines and make use of how to say it, make then this kind of things. How to say it? Be the actual geometry that moves. Like we can actually model a whole robot based on this lines because we know where the joints are, we know where the connections can be and how the connections can be, and that way we can have a pretty nice setup that helps us to really have a geometry that actually picks up this movement of this rig. So for that, I had provided you guys with a geometry that already is modeled based on this. Unfortunately, I did it back in Grasshopper since I also wanted to fabricate this somehow. And I wanted a challenge. So I did the whole thing in Grasshopper. But we are not going to, unfortunately, we don't have time to dive into Grasshopper as well today to model actually based on these lines. But I provided you guys with the model for now. But you can also experiment with your own setup. You have the lines, you have the network. You can just make some, for example, let's say for each line, for each line, we can start doing like crazy stuff. Like let's see, for example, for this one, a basic sweep. For this one as well. And the other two can be actually tiny ribbons. I don't know. So you can use these four things that we generated for segments of the line. And then I just want to have a clean setup. And then we can use, for example, I know it's not the best kind of setup, but it looks like this now. So we have this here, this one there, and these connectors are here. It would be actually nice if the sweeps also kind of had a rotation, some sort of twisting going on. I think I need to sample this curve. You know, I've got a tiny too much of a twist. What? One full twist, partial twist, yeah. Only 90 degrees is fine. Construction. Yeah. Set the construction to X, so it aligns itself here and here. The other one can be the same. Let's just copy this and paste it over here. And I will also use on this one. You don't have to tag along here. I'm just showing you that you can really be creative also about these things. So I encourage you to model something on your own. This can be also crazy organic arms wrapped around this on each arm. So I'm quite curious what you guys also came up with this setup and make use of it in a very creative way. So this is an easy way to actually get to a quite interesting geometry. Anyways, and then we can use this as and we can use this geometry to replace our line work for the grid. So for that, what we have to do is before merging it like this, we need to pack each one of these. So let's pack them back. First one is here. And for the packing, only thing that I want to define is pivot location should be the origin of the geometry. And we can pack all four in and merge them. So now what we have is we have four packed geometries. And it's actually an empty geometry, only a packed geometry is in there. Only the origin points are represented. And yeah. So now what we want to do is we want to capture packed geometry. And the capture packed geometry needs two inputs. The first one is the skin geometry. This is our skin. And the second input is the skeleton. So for that, we can directly use our full body I key. So the one that we already set on the here. So let's bring this actually down here. And now in this capturing, we can do it automatically, but most 99% of the time it doesn't work. So we need to have to do it on our own. So pack input, first of all, enable this, and then capture by attribute, skin attribute and skeleton attribute. We use names for that. And then manual capture. We need 4 of these because we have 4 different arms. And then capture geometry 0, 1, 2, 3. 0 represents the first one, second, and so on and so forth. And 1, 2, 3 are the next ones. And here, then on the joints, we can define 0 and 1 joint is for the first geometry. We don't actually have to give all of the points. We just need to have the first point or the last point. Most of the time it works like that. Here, I used 5 as 1, 1, 2. I used 3. By the way, this is a connection arm. This is a normal arm, so that's why this is the first one, this is the second geometry, then third and fourth. So first geometry, second geometry, but in this setup, it's a little bit wrapped around. So don't worry about the numbers. Just use these numbers that I'm using, then it should be fine. But if in your own setup, in this area or stage, sometimes you have to play around until you find the right number. Or you can also visualize it and see for yourself where to put which geometry. And then we need bone deform. here you will directly see if our capture geometry works. So the first input for the bone deform is from capture packed geometry. The second input is the one that comes from the rig doctor. So it's the rest point transforms, which means this local and transform attributes will be here used. So those are the original positions because now our packed geometries are in the original positions. And then the last one is the deform point transform. So the deformed one comes from the full body I key where the whole rig is transformed. And this way it can remap all of the geometry that we have now here according to those points. And immediately we see some not aligning elements, which is actually normal because what we did was we actually messed up with this is the reason why I did it, why I did it this way to explain it further. Also it's important to know which geometry is where. So the first input and the second input, according to our capture packed geometry. So the 0 and 2 are actually both are the arms. So actually this needs to be 2. So the 0.5 needs to be related to the capture geo2. And 7 needs to be, I think, 3. And 3 needs to be 1. And this way, we should have now mapped our geo perfectly. And as you can see, we don't have any that much of a deformation and so whatsoever. But yeah, this is a way to really make use, and I think I have somewhat of an issue. You know what? What I personally mostly do is, first of all, I use the arms. So I have this one and this one. So in a merge, I make sure that this one is first input, the next one arm is the next input, and then I dial in the rest of the packed geometry. So this one should be the middle piece. So this is my third geometry because this, the way I put it into a merge also defines which will be the first geometry and the second and so on. So now here, the first geometry is 0 and 1, so 0 and 1. So the rig knows where to put it. The second geometry, let's also make sure that it's properly sorted. The second geometry, we'll use the third point, it's here, or fourth, you can also put it fourth. 3, 4, or maybe, yeah, it should be fine. And the third geometry, we'll use the 5. And the last geometry, we'll use the 7. And let's see if it's not correct. If not, then you can play around until it fits. As you can also see, like I think this one fits well. This one doesn't fit well, so it needs to be actually 3. And yeah, the first one, I think we don't need this one. Yeah. Now it's fit perfectly. So actually what you can also keep in mind is it's always either a middle point, pick either a middle point, like here, for example, for 0, I pick the middle point 1 and not the 0. And for the second one, I picked the 5. So it's the end point here. And so on and so forth. Anyways, this is a way to link it. And now we can also do it with any type of geometry. And that's why I provided you guys with the driver node or OBJ. So you can bring that in with a file node. And let's go and find this file node on the resources driver. And as you can see, this is exactly based on the line work that we have. So it aligns itself to the line work. And you can see how I modeled it. All the joints are perpendicular and aligned with the whole geometry. So I have a setup. I just have to, so in this setup, I just feed in the lines and it automatically generates this 3D geometry for me. And it has no collision, so I can 3D print it and really play around with it. So for the sake of this workshop, you have like this version, but yeah, you can also use it as a reference to model it yourself. Now I will do the same operation with this one. And here what I also have is I have groups where each arm is in one group. So I can also isolate each arm. So let's go ahead and do that. Let's go create a split node. Let's deactivate the flag here and let's select arm1. So now only arm1 is selected. The second input is rest. So let's go ahead and here select arm2. And the rest should be the connectors. And here I will select point1. So now we can create nulls. So the first one is the arm1. Second arm is here. This is con1. These are all the geometries that we need for the whole skin. Sorry, I just like to have a clean setup. All right, and now we can add different kind of stuff to this setup. Like I can add extra geometry on each one of these. And also before going further, let me do an attribute delete and delete the stupid color. Now, so you guys can see properly the geometry. So here, first of all, what I want to have is I want to actually call out the, let's create a group. This is my driver. I see this as like this driver link or the main link of this whole system somehow. I don't know. Let's select all of this and deselect this part. And let's call this driver. You will see why I called this out later when we go to space modeling. And yeah, now we can do the same thing with what we did previously. We can now pack each one of these. Like you can do lots of different stuffs in between. Like you can literally amp up this whole stuff. Like I can do, for example, attribute blur on this. It's kind of have a smoother mesh or whatever. Before that, I probably need to fuse it. And this whole thing can be an organic arm. So you have the freedom of creativity to really push things further. And I will do this with both of the arms. So the arms are quite organic looking. And let's pack them with pivot location origin as origin. Here as well, the connectors. Connectors as well. And this is my tip actually. So I have quite basic tip thingy going on here. So you can also do some extra stuff here as well, like whatever. You can also attach some, you saw some of my works contains like this cables flying around with vellum and so on. You can attach those cables in this stage. And when you assign this to the rig, it will immediately assign with the correct location. And then you can use vellum on that part. Like only sky is the limit in this case, in this stage. But yeah, now I pack them and I do the same thing like before, merge them all together into one node, and then make use of the capture packed geometry. Maybe in this stage we need to change a little bit the whole thingy, but apparently we don't have to. But as you can see now the drivers are a little bit organic looking, whereas let me get rid of it. And the whole movement will be picked. And as you can see, there are no intersections whatsoever, and it's always uses the axis to move the whole thing. But yeah, any questions? Then we save now this file. Awesome. Save as. But to be honest, I'm not too much keen on this part, so I just disable this part. Let's keep it clean for now, and I will go back to previous. Yeah. And as you can see, if I also open now or reference this arc, this thing moves according to this arc or follows this. And if I select the sphere and move around the sphere is actually the whole thing that this thing attracts itself. But why is it so limited? Oh. Oh, because I was moving around the sphere itself. I have to move the transform. Now it looks much better. All right, cool. The next setup, I will add some extra elements to this geometry. And that extra stuff will help us to actually add more to the rig itself. So what if this whole thing is our element on a staircase or other kind of stuff? But yeah, let's take another break for 10 minutes. I'm gonna save this file. And let me also add a null here to finish the rig out skinned. Oh, let's call it skin rig. Output skin. And yeah, we will add some extra elements to this and let's see where it leads us. So let's come back at 20 again. So 10 minutes break, around 10 minutes. So 18, 20. And yeah, see you in a bit, guys. Welcome back, everyone. So I think we can carry on. We still got some stuff to do. So I hope you all have access to the latest file that I uploaded now for this last session. And now what I want to do with this whole setup is I actually want to add some extra details to the model that I have here that I can use later on when I have the movement and connection to the rig. So for that, let's go to the first arm. I want to add some stuff here. So what I first want to do is I actually want to also bring back the line that corresponds to the arm. So this is the arm. And let's use a split node here and connect this to my first output, out skeleton. And since I set up some groups there, I can also use R1 group here to call out geometry, but apparently we didn't set that up. No, it's all called R1, R2. Okay, that's my mistake. So normally if you set up groups, you also have to rename them accordingly. So let me save the file so you have the latest proper one. But yeah, because when I have the group name, I can then call out exactly only that part of the rig. And now what I want to do is I want to use this line in the middle to add some extra stuff there. So for that, first of all, this is only one primitive with 4 points. I want to actually extract each side of it. So let's use a carve node again. So with carve, you can also, instead of changing the length like that, you can also use 0 and 1 again and cut all internal cube breakpoints to break that into 3 primitives. And now I can go ahead and use blast node to enable the lead node selected, and I can select the middle section. So I have only this line here. Then I want to use another curve here to actually change now the length. So let's change it between 0.15 and 0.85 seconds. So now what I want to show you is I actually have like here, like this lines generation thingy. It uses a line to populate it with some perpendicular lines. So for this is a little bit vex heavy. So, well, it should be fine. So we can have also a vex exercise here as well. And let's call this wrangle perp line gen. So it's for perpendicular lines generation. Let's set this wrangle to primitives first. And first, what I want to set is I want to set some parameters. So the first parameter will be a float parameter with the name of offset, which means I want to define the length of the lines with this offset. We can also call it OFF or OF, maybe not OF, but OFF. So off stands for a channel F. So a channel F function or channel function inside wrangle means it will generate a slider. So, and under quotation marks, you can define the name of this slider or parameter. And here, offset, I will call it offset. And let's close the quotation marks and also we'll close the brackets. And with point, comma, we can close off the line. And if you press now this icon, it will generate this parameter that we want. So here we can define then the length of it, of the lines. Then I want to have an integer variable. Let's call it NB, and this will define the number of points or segments that we want to have, the segments of lines. So let's call it another channel, but this time CHF stands for float. So the parameter will be float based, so it will be a full number. And channel I, or it will be a rational number. And channel I stands for integer, and this is a full number. CHI, open brackets, open quotation marks, and call it number of PTS. So number of points. And now, if you press this icon again, it will generate this slider now. Here and here, we can define how many lines we want to have. And this is how long the line should be. Then, we can go ahead and set another variable, but this time, we want to actually store the points of this primitive that we have, like these 2 points, like the start and the end point of the primitive. We want to store it in an array or in a cluster, let's call it that. But in coding, we call it as an array, because then we want to use that array to actually bring these points into the wrangle and then segment it, this and that. So let's bring this primitive points into PPTS, and then here we need edgy brackets, empty edgy brackets, and if you write the name like this with empty edge brackets, then Houdini, wrangle, or Rex immediately knows we want to create a integer-based array of points. And this equals to print points function. So with print points function, I can bring in the points and store them in an array. So print points, our first input, you can always see the usage. It needs an integer array. And this needs a geometry as the first input and the print number. So geometry stands for the first for the inputs, and we have the input in the first, so we can type in on 0, the start, and comma is the second input. Here we need at print number. There's already a default attribute for that. The name is at print number. All right, so this is set. Now we have to actually get this each point of the primitive out of the array and store it into a vector. So vector P1 or PT1, so the point 1 of the primitive equals to a point function where we say 0, the first geometry. I want to have access the point attribute from this point. And I want to have the point number will be the PPTS in edgy brackets. I want to have the first point, so 0. So now I wrote out the point from the primitive. Oops, sorry. We can copy and paste it again. For the second point, we have to do the same thing, and where the point number, we will call it PT2. And we want to have the second point of the primitive. Since our primitive isn't that complex, it's actually a line with start and an end point. This is also really straightforward. Then what I want to also do is I want to get the midpoint of this, because what I want is I actually want the direction of the line. So I can also get the direction by calculate the direction between PT1 and PT2, but yeah, for an extra crunch, we can also get the midpoint as well. So for that vector, mid PT equals to, we can lerp. Lerp is nothing more different than a tween, or it's an interpolation between two numbers, values, or points. So here you can use any type of thing. So you can also see that when you make a function and open brackets, it immediately shows you the info box and explains what it does. It performs linear interpolation between the values. So it can be a float, it can be a vector, whatsoever. So in LERP, I have to define the vectors pt1, pt2, and then a value that shows me the midpoint, so 0.5 will be exactly the midpoint. Then I want to drive two vectors. So direction 1, and this should equal to pt1 minus midpoint. And the vector direction 2 is the same thing, but this time pt2 minus midpoint. And then what I want to do is, yeah, to be honest, we don't really need this both. Again, I did a different type of solution here, so I actually moved it, like it opened up like this, because now what I want to do is I want to actually have a control over also the rotation of the line, so I can define if I want to change the setup. I can also rotate the extra lines that I generate, so I can play around with that. So that's why I will need now a vector that uses one of these vectors, and it's kind of, we just remap the vector in a way that it's perpendicular to the previous vector. So here I will just use the different name, normal direction, or let's call it ndir, equals 2. And here I can set also a vector. And here, now I will use each coordinates of the vector, like x, y, and z, and shuffle them. And there I shuffled it with direction z. So instead of x, I use as a first coordinate direction z of dir1, so dir1z. Then dir1x as the y value, and dir1y as the z value. Yeah. Now, what I need is, I also need a parameter to define the angle of a rotation. So float angle equals to, and here we have to change it to radians. So I want to use a channel where I define it in degrees, and in code it changes into radians, because most of the time that way it works for me personally as the best. So radians function, and inside radians function I will generate this channel f with the name angle. Let's flag it, or let's generate it, and here we can just give any type of angle. And now the fun part, let's actually make the matrix to rotate it. So this is, here I set up a matrix M float or variable, which is also, we don't really use the ident function here. And it uses the identity matrix, it's like the default matrix. And it's important because in in a rotation transform, you need actually a matrix, because we not only we use two transforms, we use more than, it's not a linear process. You have direction, vector, but also you need the angle and the default position in order to make the rotation properly. So that's why it's always good to, if you want to transform anything in this regard in in a wrangle or in vex, you need this kind of matrix setup. Anyways, then we use the rotate function, and here this rotate, oops, I just have to spell it correctly, applies a rotation to the given matrix. So here we need the matrix M, and our float amount is mostly the angle and the vector for the axis. So what we need is the M, the ident matrix that is set for this geometry. Then we need the angle that is set here, and we need the direction 1 as our direction axis. So because we want to rotate it actually in this direction, so that's why we use this as the rotation axis. And then only thing what we have to do is now we use this end here. So end here should be our normal direction towards this from this line. So we just multiply this end here multiplied equals. So you don't have to like, normally you do it like n dir equals to n dir multiplied by m. So normally you do it this way, but in Houdini or Wrangle, you can also write it like this, n dir multiply equals. So it immediately knows you're multiplying already the end product. So you can also write it in like this. And yeah, that's basically it for the rotation setup. Now what we have to do is we actually have to create the lines. So what we can do now is we can actually use before going forward with the for each loop, let's do it in a very normal way. Let's create a vector here. Let's call it position. And, or actually, we already got our position. It's this midpoint. We can use the midpoint. Then n mid, so this will be our vector n mid. It will be the new midpoint equals to the mid pt, so mid pt plus this direction and there multiplied by offset. And then let's create an integer for the midpoint itself. So mid p equals to add points. We also need to add these points to the geometry. For now, all of this stuff that we did, it's stored in the wrangle. It's not stored in there. We didn't actually cooked it or baked it into the geometry. Now with add point, I'm going to add this point to the geometry so it's visible outside as well. So 8 points to the first input, so to the main geometry. And here I'm going to add the mid pt and int another integer. I call it integer because this needs to be stored with numbers. So it's a 0, 1, 2, 3 numbers because this is the identification of this point. So when you go to geometry spreadsheet, each point of the geometry, let's go to the point, has like not only the point coordinates and color in this case, but also this point number 0 and 1. And in order to bring it out, you need to assign it to a number that it will be the ID number or point number of that source. So that's why this add point only accepts integer. But then mid P2 will be the offsetted point using the normal. So add point 0 and mid. Now we have like as you can see, it added this point. Normally we don't have that point there, but it added that point. And now if I start offsetting it, it should start to see some stuff. Oh. No, it's not offsetting. Ah, it already offsetting. It was just so high, I didn't see. But yeah, as you can see now, I can control this. And if I change the angle, it should also start rotating around this axis. And I think I messed up the axis a tiny bit because, yeah, direction. Yeah, maybe I can leave this as X. Normally, it's only enough to change these two. But yeah, it does almost the same thing. It's fine. You can also, after this, we can also use end here equals to normalize end here. So I can also normalize the whole vector. So it's because now the issue is the what's it called? The distance can vary, and that's why it's kind of oval. Normally you do it in a mathematical sense, you do it a little bit differently than this, but this was like a hard thing that I did back then. So you can definitely copy it because since also we have like a very clear shape here, I would never use like very random angles. I will only use like 90. As soon as this perpendicular, like it functions in a perpendicular sense properly, like 180 is down there, then 270 is right, left, and this way you can really change this angle properly. Let's keep it at 90, like towards outside. But yeah, as you can see, now we have this setup where we can actually also we can draw a line in between now these 2 points. And this is also done very similarly. So we can add another integer, but this time for, let's call it line equals to, and here we can use add prim this time to add the line. So add prim to my first input for main geometry 0. And here in the second, we can define, will it be a polygon? So will it be a closed poly surface, or will it be a polyline? And this will be a polyline, so you can just type in the name polyline, and Wrangle or Vex immediately knows that it will be a polyline. And then we need the starting point, mid P and mid P2 to the end point, and it immediately draws this line in between. So yeah, this is basically. Yeah, it's a very method. Methods are very linear, and step by step you can create like this very complex thing. But in its, how should I say, when you lay down everything, every workflow, it's actually quite simple steps or simple mathematics or simple functions. But yeah, it's like a very like a different type of design process. That's for sure. But yeah, this is basically it. But what I actually want is I actually want an array of lines here. I don't only want one line. I want actually a bunch of lines that I can define how many lines I want and so on and so forth. So for that, we need a for each loop or for loop. So this is kind of getting a little bit more interesting because for for loop we can define like it's like an iteration, like first iteration it generates one, and then second and third, blah blah blah. So it is like this growth kind of idea. So it will do like it will first create like based on a certain step, it will create a point, create line, and then the next iteration same. So we define a certain kind of logic or certain kind of rule or workflow, and we iterate on that workflow a bunch of times until it meets our limit. So for, we say integer, we set an integer for the loop, and let's call it n for a number for purposes equals to 1. So at the start, it starts with 1. Then it needs to separate it by point, comma. Then I want to set as here you can define how many iterations I want, but I want this n to be smaller than, so it can't go beyond this number of points that I set, and it's called nb, so n smaller than nb, so number, point, comma, and then n plus plus means it is it builds itself up. Then we need to open now, after closing the bracket, we need to open our curly brackets and close it immediately. And in between these two brackets, we can now set our workflow that we want to iterate on. And it's actually the exact same thing that we had here, down here. We just create a vector and then, or we create a point, then we offset the point, we create a vector, and then we iterate on that. So, but this workflow here doesn't function. We have to create our own midpoints because we also don't want to use the normal midpoint. We want to have a midpoint scattered, or we want to scattered points, and then we want to offset those points. So for that, I will create a float, and this float will be my lerp value. So lerp value, it's like the same thing that we did to get the midpoint actually. So let's create this value based on the number of amounts of iterations we will have. And this is a super basic mathematical function that we can use. So lerp value needs to be the n, so each iteration number that we have, n, multiplied by 1 divided nb. So 1 divided by nb means it's like the first one will be 1 divided by, in this case, let's call it 10. So if we divide the 1 will be like this will be 15, and 15 divided, or 1 divided by 15 is around here. And then it builds up according to that. I hope it makes sense. Like, I was pretty good at mathematics, but explaining what mathematics was always not my jam. But yeah. Anyways, especially if you want to explain this, you need a table to draw it. Like NB is like the full length. And then we just select only the first part and second, so on and so forth. Anyways, then we need the vector. And this will be the position that we want to set. And position is, again, the lerp function between pt1 and pt2. And here we will use the lerp value. Just make sure you're given don't make typos. And then the same thing that we did down here, we want to have another vector. And this will be the npos for new position, where we use the position multiplied or plus the direction, the n there, multiplied by offset. And actually, I'm going to delete all of this and copy this part inside there. So we're going to have to rewrite it. And here I will just change this one as P1, this one as P2, and this one as P1, this one as P2. And I also have to change the names of these ones. And yeah, I just told you guys don't make typos, and I made one. But yeah. Now, and I also normally this should already have everything. I think this needs to be set. Yeah, and make sure this needs to be wrote. I just wrote. You guys see the difference. If I wrote it as an integer, this float function won't pick it up. Just make sure to add point comma here. I know it's a little bit tricky. I don't know why they made it like this, but yeah. And now with this setup, you can immediately divide the line um, into segments and then draw lines according a certain angle and offset. So this is, for example, you can use the script for any kind of line. Like, for example, if I had a different type of polyline, I can also use it, for example, the whole thing. Let me put this one here. It only uses the first and the second input. And as you can see, this here, it also draws it, but the issue are we don't actually have the each line, so I need actually have to use carve to digest. But yeah, here if you have like some setup like this, you need to have custom vectors on each lines. But yeah, this is a nice script to really. It's quite simple and straightforward. So you can definitely save this as a preset to use every here and there. I want to use now 20 points, around 20 points. And now I can merge this with this one. I actually have this also out in the skin. As you can see now, these lines are following the geometry as well. We can do so much stuff with those lines. Like we can also put it into a vellum, so this can be cables all of a sudden. Whatsoever. Or we can also do some different type of things with it. But before carrying on, I also want to set attributes because we have like these 2 points. I also want to distinguish each point with a certain kind of, because when I want to put, for example, I can also use this as a line as well. And I want to select exactly this edge to put something there. Like you see my panels that are also attached to the system. I use like this kind of reference points to pick on which side or where to attach this geometry. And so that's why I also like to add a set point attribute. So I want to set some point attribute only on certain points. So 0, and this will be PID, so point ID. And here I will use the P1. So the first point should have the value 0. And I will do it again, set point attribute 0. You guys will see why I do this in a bit. And here I will use P2 as 1. And now if I do this, and what I also have to do is our initial line is still visible. I just want to remove that. So let's use remove prim 0 at prim num1. If you also do this function, the initial primitive will be gone. So we only have these lines. But now we also have like this PID, point ID. If you visualize it, you don't see anything. You can now go to this icon, right click, go to PID point attribute, press on this edit button. And here instead of color, I want to have a marker. And here you can see the point, each point has like an ID. All of these points has 0 and all of these ones has 1. Now I can use a skin attribute to actually make a polygon out of this. And here under the skin, you can also change the connectivity to something like columns, where I have this line and this line. So yeah, and I can identify this network immediately because I have the attributes to identify it with. So I can say select only the geometry with PID 0, then it will only select this one. But yeah, another also thing is I like to have both of these input. So I want to have these lines. These lines should be the, let's call them segment lines. And let's call this one base lines. And that's basically it. Now I have the whole setup ready to be shipped. Because now outside here, I can come here and say, after baking it, first of all, I can unpack it. Let's get rid of this. And then I can do a split node here. Since I also have all of these groups still intact, I can select anything I want here. Like for example, here I only want the baselines, and all of a sudden I will only have the baseline. And now here I can do things like, for example, I can go ahead and say delete. And here I can go to the operation, delete by expression, and here I can say add PID equals to, so I have to do double equal sign equals to 0. When PID equals to 0, delete it, I don't want it, and it will delete the in line, so the outer line will be visible. And now I can just go ahead and use, for example, fully extrude or something like that to start modeling or using this as a reference to model something. But yeah, since the normals are also changing, I wouldn't recommend doing it this way. You have to do it almost a little bit properly. Like I think here it needs to be quite normal. So but we don't have any normals yet. But yeah, this is a super hard raw thing. But what we will do is a little bit different than this. But yeah, another application that you guys can also do is, instead of using now the space lines, I will use the segment lines. Then I can say group, or I can resample the segment lines to add more detail to it. To add more segments, and let's call it maximum segments 10 or something. And let's use group node and use the second input as my collision source. And here, disable this one. Let's call this pin PT, so pinpoints, group type to points, and then bounding regions. And here I will select bounding object. So all of these intersecting lines will be selected as pinpoints, rest not. Then I can go ahead and put this into a vellum. Configure cloth. Vellum geometry. And here I can define the pinpoints, match animation, since it's also a moving piece. It also has to match the animation, the pinpoints, and then a vellum solver. Now let's see if this one works immediately. It's already calculating. Yeah. Now, as you can see, you can also use it as a, I also have to set the second input as my collision as well. So let's do that as well. So now I'm curious. Yeah, nice. As you can see, these cables are attached, and you can do the same thing with the other arm as well. So you have like these cables flying out. Like I think you guys saw some animations, previous animations in that direction. This was how I actually did it. And as you can see, like you can do this kind of stuff quite easily. But yeah, I'm just gonna leave this part as like somewhere on the site so you guys can access it. So the stand-in part. What we want to do with this setup is something completely different. I think since we have only 1 hour left, now I have to go a little bit fast mode because what we actually want to do now is we actually want to have a setup that kind of generates like the stair-like look. But yeah, we are almost there, guys. It's hanging there. Meanwhile, I'm gonna save this file so you have access to it, and we will carry on from there. Save as, and let's save it as setup. What do we call it? Let's call it 0, or skin adjustments. Maybe it would have been also better if I would have done that 04. Yeah, I'm gonna rename the files later. This is the fourth file, skin adjustments. So, any questions until now? Any comments? Anything that you also are curious about? Now is the chance to ask them. So, I think there are no questions, which is, I don't know if it's great or not. Are you guys? I hope you guys are not overwhelmed or super bored. But yeah, it should be fun. Anyways, what you can also do with the setup is you can also start arraying it, which means, or before we can also, I showed you guys, for example, we created these groups for this head here, the driver. Let's actually go ahead and make use of it. So here I will do a blast node. Actually, I just want to have some sort of a connector setup where this is not flying around, but actually is connected to somewhere. So here I will use this driver head, delete node selected. Then you can use a fuse node. We need a fuse node since it's an important geometry. Sometimes it's not connected properly. So let's do that. Then I will use a bound component to actually get the bounding box of it. And then I just want to blast a couple of sides. So let's go to blast node. And let's select some sides to delete. And I don't like to have these sides. So I want to have like this kind of opening. Or actually, all the way around. I want to delete this, and this. Awesome. Oops, I selected one side. So it looks like almost the same setup that I have here, only like it holds this thing together. So I actually want to create like this column where this thing is set. And then can actually start doing some sort of extrusions, like let's do a poly extrude. So here, this is basic modeling inside, this is procedural modeling inside Houdini, not like nuclear science. So I just create like this kind of element, then yeah. So I can also do different kind of stuff, like for example, I can just blast only the bottom section here. Let's get this bottom section, delete not selected. Let's go and do a bevel. Let's bevel this thing out, but this thing is too, I need the points for the bevel. So you have to set the group type to points, not primitives, to points, and then this will also bevel face edges. And let's do it round with lots of stuff. I think this looks fine. And let's use poly extrude to actually create our column. So that's basically it. And let's merge these two together. And in the end, we have already like this type of setup. It's quite cute. And yeah, if you also want, we can also create like a poly extrude before. You can select this face, do some insetting to have also much more thinner, a little bit more thinner. And here in the front, we can extrude the front. And here on the blast, instead of choosing a point number, we can choose the group name. And then we have here also control over the thickness. And I also don't like the sharp edges here. We can also add a bevel node here. So let's select these edges. So go to this icon, select edges, select only these edges, and then let's bevel them out, make them round. So overall look will be the same. Nice. So this is our driver head setup. So I'm going to copy this over there. I don't like this connection. All right. So we got this. We have our main geometry around here. So let's merge them together. So we have our column and also our arm. Now it's cutely assigned to a mailbox. Looks like a mailbox. That's fine. And what we want to do now is we actually want to array this towards a certain direction and go a little bit more crazier. So for that, we can use for each number component. And with this, you can actually use the, of course, you can use copy and transform. Like this is the cheapest way to do it. Copy it like 5 times. And let's move it towards the X direction 10. Of course, we can do something like this, but as you can see, all of these are moving quite, like, not quite, but they're moving simultaneously. There is no drag and there's no type of organic flow of things from first to last. they are all synchronized perfectly. So that's why I like to use for each number. So I want to set like I have one, the next one I want to move like for on x-axis for 10 units. And but I also want to rotate it, but I also have a time shift. So with this, I can set up a certain statement or workflow, and I can repeat that on iteratively. And this would give me also a shift in the movement, this and that I can't get with copy and transform. So first of all, let's use a time shift, or not. Let's use a actually let's use a um, wrangle first. Attribute wrangle to actually transform this. So for now, we have like you don't really have a certain kind of logic. Go to the for each end. This needs to be set to merge each iteration, and by counting here, I don't want to have too many. Let's set it to 3. And for each begin, here, let's see, I would definitely, if it's set on fetch feedback, change it to fetch input. I only want to have an input, and then I want to merge each iteration. And then we have also this metadata. So here we have access to iteration, number of iterations, value, iteration value. These are detailed attributes that I can use in my workflow to define, okay, the first iteration uses 0, the second 1, the third 2. So this means I can define how far something goes with the increasing iteration number. So for that, I would use this metadata as second input, and first input is my first main geometry input. And here, as a code, first of all, I need an integer value or variable with the name iteration. So I want to bring in this detailed iteration value into the code. So I call it ITE. And let's use detail function to bring in, and I want to use the geometry handle, the second one. The value that I'm seeking is coming from the second input. So 1, comma, the name is iteration. That's it. And then I also want to have the number of iterations. So num-iter. It's a nice name. Detail 1, and here num iterations. Then I want to create a float value. Let's call it t. So this will be the time frame or iteration frame. And here, a basic mathematical function again. So iteration number is almost the same like we did earlier. So the current iteration number divided by number of iterations. So num-iter. And here I always like to add -1 because the last one doesn't add. Okay, we don't need the last iteration number. You're welcome, Nitesh. Good luck with the work or at the work. And yeah, here we also want to multiply this with iteration. So then I want to set up the depth. So it's actually the float depth equals to channel depth, or let's call it actually it's the z direction. So float z, let's call it z here. Then let's create actually xyz directly. So So x, y, z. I need three values for each side. So I'm actually rebuilding the transform component here, but this transform component will have iterations linked to it. So it means it can do iteration-based transformation. All right. So I set now this, and now I need the depth, the position. So actually, I only thing that we have to do is p point x. So the x position of the points should be added with, yes, I modeled it externally, but you can also model it inside Houdini. I just didn't show how I modeled it because we don't really have time to do it here. But the main thing is you have to use the lines to model the skin, the driver skin. So when you attach them with the rig, Houdini, the body rig or the bone deform component immediately attaches it based on the line positions. So you don't have any intersections or flying pieces around. All right. Anyways, the point position, I just want to add the uh, here, yeah, the ITE. And let me create this. This doesn't make sense. Yeah, we need the depth position here. Yeah, float. We need another thingy, and that's the depth toss for the and here what I want to have is, oh, actually, I had it right. It needs to be multiplied. Okay. Yeah, anyways, I create a depth position for depth. But before using that, I need I will use here the x value divided by number of iteration minus 1 multiplied by ITE. Yes, exactly. But you can also do it beforehand. Like I also in the latest works, the robotic arms, I did this not after the rig, but before the rig. So each one of the rigs had their own I-key setups or full body I-key setups. Yeah. So there are different kind of ways how you add plus x multiplied by that percent. Something. Yeah. That was x is this. Where do I actually use the p? Oh, this needs to be. Yeah, fetching. Yeah, something isn't working right now. I think this is this code. I have a typo somewhere. I have to find it. So that's false. Divided by crazy. 6. Oh, now I got it. Ay. I thought I had plus. See, you guys, this is one small mistake. Like if this is multiplied, then this goes mayhem. So this is how fragile coding is. But yeah, this is now the copy. It looks like copy and transform at first, but what we have here differently is I can also apply different type of uh, transformations to this one now. Now let's do the same thing for all three of them. Def plus x. Let's call it also def plus x. Let's copy this also 3 times. Y, z, x, y, z, y. And now we can first of all create our first setup with the positioning of the whole thing, where I have as a y, I think y direction is around 30. Oh, I also have to change this. I was like, why is it only the changing it towards the x-axis? So 30, then z direction, I think I had it here around 220 something, or minus 220. And this, let's keep it at 0. It kind of goes towards this direction. Doesn't also make sure that there is no intersection and this kind of stuff. But looks good. Now, what I also want to add is rotation. However, I wouldn't recommend doing it inside Vex. That's kind of tricky. You have to tackle along matrices again. So you can also use a normal transform here. Use the first input here. And here we can create a spare input. So add spare input, and we can link this metadata with the transform. So it will generate like this purple line, which means, okay, it's not directly connected, but it's connected. And now I can use the detail function here in the parameter itself. So you can also dial in, like, for example, detail -1. If it's a spare input like this, you have to dial in -1, not 0, 1, 2, 3, whatsoever. So -1, the name iteration, and 0. And this will immediately give me the iteration number as an input. Now I have a typo somewhere. Here I forgot the quotation mark end. And now if I add like 10 plus, and it will also start, God, this needs to be 1. Oh, no. Yeah. Oh, I have to multiply this. yeah. I don't know why, but at work I'm using an English keyboard, and in my personal keyboard I have a German one. So the plus and multiply buttons, they are completely messed up. Why can't they do a one universal keyboard? Like everywhere it's different. But yeah, here you can now iteratively start rotating them as well. So it generates like this organic look. And we can now copy this for each one of these axes. So we have control over each axis. And now let's set up, like, I think here in this first one, I don't want to have any rotation. So let's set it to 0. The second one, 5 is our oops number. And in the last one, let's set it to -10, actually, the other direction. Something like this. It's quite, this looks nice. Kind of folds itself, and it's quite straight. And then it's open, or it closes itself somehow. Nice. But yeah, feel free to play around with these. And another thing, now the animation itself. The animation is still synchronized, so they're moving at the same speed or at the same time segment. We can also use now time shift. In here, we can add a spare input here as well. Bam. And here, yeah, the thing is, you can do it here is only design purpose. I want to define the position and so on and so forth. But I know like how it will move anyways. In the next stage, like in my personal works, I also had like this prototyping process where I had like motors, like 60, like 6 motors, and each motor were programmed almost the same way that I have it here now. I did it back then. The programming was based in, I did it in Touch Designer though, but in the end of the day, the logic was exactly the same. So here, what I gather here is mostly concept, but in the future, hopefully, I will also define here the movement as well. Here, all of these stuff that I get here, like the position of the movement and so on, I can also relink it here as well. So I get the attributes and so on and so forth. So I know that, for example, the first one is in the time frame here, but the second one is 20 frames ahead of it, which means the position is also 20 frames ahead. So I can just calculate the value for each one that way. So I can mimic one-to-one how each one of these arms should move. And another thing is the positioning is based on only this pillar, to be honest. The rest is, if the pillar is to a certain degree, because the geometry itself only shapes based on the movement. It doesn't shapes in itself. So you can have this geometry printed, but the position defines the form actually. And if you know the position, or if you know the position of the target, or how to program that, you can one-to-one mimic this in real as well. I hope it makes sense. Yes, that would be amazing. Like also, it shouldn't be like this industrial robot thing. It's like I think it can also be very um, bespoke mechanical arms that have like functionalities like um, beyond that. Like these kind of logics or robotic movements can be easily made functional. But yeah, now with time shift, you can do the same thing as well. Let's do it as I think for now we only planned it this one time, but let's see. Let's see what future brings. we can delete this channel now, frame. And here I can just copy and paste this detail function. And let's say on each iteration, can you please add like 20 frames? Or yeah, in the end, like let's call it $F. So it still needs to flow with the frame number, but I want to add to this $F. See, again, it just does this multiply times $F plus multiplied by 10. So I want to multiply each iteration by 10. And as you can see now, the movement also isn't synchronized at all. So you can clearly see. And yeah, so, or let's say actually 20, much better. See, all of a sudden this is far, far, far ahead. But yeah, you can experiment with this. Now, let's build the stairs real quick. And for that, now we have like our pack geometry, everything is set up. We can now unpack it. And by the way, we can always add more iterations to it. But yeah, be aware, if you do that, you also have to adjust the size and so on, so it doesn't have these intersections. Anyways, this looks quite nice. Let's unpack it so we have access to the geometry. And first, what I like to do mostly is I just get like this split, and also what I want to use to split is I want to split it based on the baselines. So these lines that we generated here. And in the baselines, let's use, since we have like all of the segments on each line, I want to use facet to actually remove the inline point. So I only have like really basic lines. And then I will use delete component to delete by expression. And here I will say at pit, like I showed you earlier, equals to 0. I want to delete that one. So I can have like I can access to the endpoint here. Then I wanna create a skin node. Actually, make a geometry follow these lines. So when this moves, this geometry follows exactly that. And as you can see, I think the position of the baseline, I don't like it that much because as you can see, it kind of looks towards the direction that it doesn't benefit me. And this is the key here. Now I can start rotating it in a direction that it works. Like I think 90 degrees was the good one. Now a certain geometry is attached to it, and it follows also the robotic movement that I have. Then I can use like a divide nodes to actually divide it. It's quite, from here on, it's like mostly recognizing the elements that I want to use and really building a geometry in between. And another thing that we can also do is we can also use, before moving ahead with this one, I also want to connect this like a bridge or a stair. So you can also use, instead of skin, add node, but not here in this geometry. And let's go to polygons by group. So you can have like a connection like this, or you can also go here and skip every endpoint. So we have connection like that. And let's delete geometry, but keep the points so we don't have the inline points. And this will automatically generate like these two lines, so the two primitives. And I can now go ahead and blast one of these. Let's blast the top one. So group number one. And with middle mouse click on parameter, you can change the number as you wish. So that's what I did here. Then I will use now a mirror component to actually have like this mirrored effect. And here I want to reverse it. Distance should be 50 here. And the direction should be, I think, the other way around. And now I can resample this. And add like a tiny bit more. So then I want to resample one polygon edge. So let's do it this way. And let's divide each edge with 3 seconds. So I still want to, if you don't do it with polygon edge, as you can see, at some points the curve isn't attached to the geometry anymore. Then I want to use a skin here to actually connect this, but this is quite crucial now, because if you mirror it, it will also mirror the orientation of the line, so which means it's exactly the opposite. So when you skin it, it will look like this. So the first point is here and the other one. So what you want to do here is, while doing the reverse, just do it with no change. So it mirrors it as it is. Then, carrying on, we can do this mirror on the other side as well. So now we have like here some setup like this. So I can use the same mirror there as well. And let's link that. So if I change this mirror, I also want this other one to change as well. So let me just copy all the parameters here. I only need this one. Copy parameter, or copy parameter, and here direction paste relative reference. And then the other one, copy parameter, paste relative reference. Wait. I copied the wrong parameter direction. It's also getting late here. Now, so it is now aligned each other. So here I have the skin, and then here I have the railing kind of a thingy. And that railing is kind of attached to the robotic movement, so it gets small, but also gets big based on the position of the person or of the object. And yeah, let's try to kind of make this geometry much more usable. Let's do an attribute delete. I have so much attributes in here, like all this pit, this kind of stuff, like path, rest length, and so on. So let's do an attribute delete, and delete actually all the non-selected ones, so I have a clean geometry. And I do the same thing with the other one as well. And I also want to delete the group. I also want to delete the groups that I don't want to have. And here on the group names, you can just put a star symbol or letter. It will delete all the unwanted groups. So it's a clean. So what I want to do with this one is I actually want to create like steps. For that, I normally have a script, but like I think showing that immediately here. It's not a small script, but I'm gonna insert it here so you guys will have access to it, but I'm gonna explain it real quick. Since we are short on time, we only got 20 minutes left. So I have to be a little bit quicker here. So after group delete, I'm just gonna use this, or actually I'm gonna use this attribute delete and so on afterwards. So what this does is it kind of generates this kind of steps based on the look. So what I do is I actually have like this one, looks like a primitives with primitive split. I'm splitting all of these each faces. So it's like a exploded mesh kind of a thingy. Then with connectivity, I can just check the connectivity of each piece. And before each primitive, I can just do an operation on one primitives and iterate on all of them. And here and for each, I have like this attribute wrangle. What I do is I use again an array of primitives. This time I store all of them. But you actually don't need this part. But anyways, what I do is I get the primitive points. I extract all of the corner points, and then I just move 2 points of each primitive to the other point's height. So in the end of the day, it's a flat planar surface. So that's what I do here. But you can check this code out, and if you got any questions or improvements, please let me know. And I think here in this stage, we don't need this part because, yeah, because I said so. No, I'm just kidding. This will still be a trick. I normally have this script outside, so you don't actually need an extra. Just something. I'm just cleaning it up so for you to understand it a little bit better. So it's quite straightforward setup. So yeah, I will leave it in here. So I've got the railing, I've got the steps. By the way, also my mouse isn't working properly, so today is like the best day, it seems. Anyways, you can also, I think I can reverse this whole thing. It's won't benefit us, it's fine. Anyways, now as an extra detail, what you guys can also have is for some yeah. So I can put now this one here. So we can also add, like, for now, these steps are floating in the air. So what we also might want is, and also the steps should go downwards. So we can change only, like, for example, 2 and 3, and here 2, 1, 2, 3, 4, 3. And this already will MPT2. So now it's going downwards. Please check out this script and try to understand it. That's a homework from my end to you guys. But it's quite straightforward. But yeah, now let's create something that kind of closes this part. So this is also quite easy to make. So we can just use a skin component. Can then go ahead and to get the skin kind of generates like this kind of tube. So I want the columns, so I want the lines. And then I will add another skin. Yeah, I will add another skin. And this time I will use quadrilaters, quadrilateral, I can't spell it. And here groups or skip at every end and every first, not so groups of 2. And this for groups of 2, so this 2, this 2. And then you have like this closure of the sides. And now we can add some, yeah, we can divide it, or I can actually output this as triangles. 2 lines, yeah. Should be fine. And then let's add some poly extrusion, poly extrude, give it a thickness, output back. So these are my steps. So I'm also going to add a poly extrusion here. Let's merge them together, all of them. So this is my railing. And also for the railing, I want to add some detail as well. As you can see, it's like playing around, finding the spots and adding some geometry here and there, but everything is linked together based on only this baselines. So when the robot change, all of this stair will change as well. So that's the main idea of the whole thing, all set up. Now for this railing, what I want to do is let's do a poly extrude. Oops. And let's do individual elements, inset. I remember, so we have like this inset going on. Let's do like 0.2. And I also want to output the extrude front proof. Let's split it here. The first one, extrude front. First one, I will extrude it and give it a thickness. It's like 2 units, maybe even more than that. And the second one, I will just fully wire it. And I'm not sure if I will use the side surfaces. And then, yeah, this should be fine. Here I already had like, I gave it a thickness. Let's give it a little bit more depth. And then the other one is this one. Let's extrude this also around 1 unit. All right, so let's combine everything together and let's see how it looks. This is our steps. You can kind of fly. And then let's merge this setup with our initial setup and see how it looks. As you can see, this is attached perfectly to the stair and to the robotic arm. And when it moves, the whole stair moves. It also has like let's also mirror this. So I'm gonna copy this one mirror that I had here towards here as well. And here I'm gonna reverse it. So I have to. As you can see, when let's see if this attraction works. So the sphere is somewhere around here. Let's move it actually somewhere that makes sense. Actually, we have to reverse the, right? You can see like how it reacts to the movement of the person. And yeah, you can define like, for example, if it's closed, it's now closed as well. Yes, Ralph. You can just, if you have a question, you can just put it into the chat. But we are almost there for the Q&A, so. Here you can go to the range that we set here, and we can just change the minimum and maximum range to, instead of 0, 1, to all the way around. So if the sphere is closed, it's kind of open. If it goes black, closes itself. But yeah, there are a lot of ways to play around with this setup. Anyways, messed up a little bit. And also the time shift. I would do actually a minus here. Yeah, it should be fine. Anyways, this is the whole thing. Yeah, it's like it's super crazy what you can do in here. Like especially in a geometrical sense or also architectural. I'm also like I'm currently working on a competition where it's not like it's not easily comparable. And this is still design. This is still you can still do lots of creative things with it, but like the difference of possibilities, it's there. Like as you can see now, the ball is approaching or the person's approaching, and all of a sudden this thing opens itself up. And just imagine a staircase like that. Like definitely play around with it. Like this is like a super straightforward setup. What you can do instead of like the staircase stuff, you can use the space lines to or this line to generate floors and different types of architectural setups. This can be facade elements, for example. Like feel free to definitely tackle into this kind of questioneering and experimenting. Yes, Let me just clean this file up. I think I still need to do some extra stuff here. Especially, yeah. And yeah, I think this is basically it. Yeah, I would recommend, like with Houdini Apprentice, you can't really render anything. So you need a license for that. And so I would recommend, for example, if you want to render this out, just go like do a file cache, and you can export it as an OBJ sequence, and then import that OBJ sequence into Blender or Maya or any kind of software where you can render it out. Since this is not a point simulation or something like that, this is real geometry, you can easily bring it into another software for rendering. Like at first, when I was doing most of my previous works, yes, exactly. Like, and you can't render in a high resolution, unfortunately. Now, let me just clean this whole thing up a little bit so you guys can understand. Like, let's create a loop here. All this. Do I have any loops? Yeah, delete. Or actually, bring this to that voice down here. So what I would like to do in the end is, especially for those who were in my other workshops, I always like to, in the end, delete everything and create the final group, like calling it, for example, this can be the rating. Then the other one, this is, here I will do the same thing, attribute delete. And this is the railing frame. And same thing goes here as well. These are the steps, I think. Yes, these are the steps. And this one, step frame, steps frame. And then this is the driver. Actually, here I believe, yeah, driver. So in the end, I have like this merge geometry with each geometry is called out in a group, and here as well. So I have all of this bundled together. And in the end, I can just do some normal calculation. And also if you want UVs and all of that. So when you export it or use it in any kind of sense, it's already diverted into proper elements. And of course here, maybe, just maybe, I don't really delete every group because I have also other stuff here, which is quite nice, like each arm, you can use it. So I will leave those. And I also want to have maybe driver. Oh no, it's fine. So yeah. Yeah, let me just quickly use this. Select everything that I want to delete. before saving it, I just want to have a clean plan. So now you have like an output with each arm and the other extra elements. And let's call create a null. And by the way, this pillar, we can also use a group here. I will get back to your questions once I finish the file. Benjamin, group name, pillar. So here I will also have the pillar. Yeah. Now we have in the end outputs. I know with each part are separated and can be used in different kind of random softwares to get the material, and also if you want to call them out one by one, you can do that. And also we also need to materialize the in-between lines here. So you can also do it here with a split base lines and the segment lines. And let's create a polywire here. So, oh, I had to invert the selections. But anyways, here with polywire, I can also make this connectors. And let's create a group here as well. Yeah, I know it's not the cleanest geometry. I have like some fusing needs to be done. But yeah, no. Yes, I will resend it in a bit. Just give me. Okay, then let's call this one connector. So yeah, now everything as a geometry is in there. And also we have to, guess what? I had to mirror it first. Yeah. Yeah, this looks kind of slick. Anyways, let me save this file so everyone has it. There's 05 final. The link to the folder. I'm sharing it again. So all right. So I think we have everything settled. Now back to the questions. All right. So Benjamin has some. So how did you get started in architecture, and how did you begin to integrate Houdini into your workflow when you began? So like Houdini came along a little bit later, but I started like a very I wouldn't say super traditional, because the university that I went, Innsbruck, is quite an experimental one, and also the institutes that I mostly involved myself in was quite an experimental architecture heavy institute. So most of my works were always been like really crazy, this and that. And sooner or later, Houdini was introduced to me because I was using Grasshopper and Maya most of the time. And when I first heard of Houdini, I immediately wanted to try it out. And since my knowledge in Grasshopper and Maya was quite in a good level, it wasn't that hard to transition to Houdini. And then I just like, I think in my nature, I like to question things. I don't like to repeat stuff. I always like to build on stuff. So if you look into my works, most of them are like always building up a series. Like it always has a link to the previous one, but it always adds something new to that. And yeah, so in my free time during studying and also working, I always like to do create stuff. And yeah, that's how I actually get into this, all of these kind of stuff. And for Houdini, there are lots of resources. And Vex, I would recommend Vex. Learning Vex, there is this CG wiki from Tokero. I'm gonna link it here. There is like this one course. It's like written course. So it's like a written course, but it explains everything about Vex. And here you also have other resources regarding to Houdini where you can really one step by step learn it. But I would recommend learning it by doing it. So always try things out. Don't only watch stuff. Like especially I encourage everyone here to really don't do what I did. Try to make your own thing with this setup. Like try something different. And while trying it, you will encounter some stuff that you don't know your way around, but then you will search for solutions for those problems. And all of this kind of back and forth will help you to really learn this software. But yeah, and definitely the sensei of all the kind of enthusiasts, I think Junihiro Horikawa, he also has some crazy good tutorials. But yeah, I think the link that also Mike just shared, it's also really nice. But there are a lot of beginner courses out there that you can check. But the main thing is repetition and doing it. You really have to learn it by doing it. Then yeah, can you? Yeah, it depends on the way that we are going. And I think yes, definitely, because the data-driven design is coming more into the focus of a lot of architectural firms. And I think the whole interface of Houdini and with attributes and also the workflows, the attribute-based workflows enables a lot of possibilities with that data-driven design. Grasshopper is super fine, but the issue with Grasshopper is most of the time the performance issues. So if you have like a huge chunk of data, bringing it into Grasshopper and trying to use it for a design process is always a big headache. But in Houdini, you can animate this. Like you can have like millions of data and you can literally animate it. Then my route to UN Studio, to be honest, I just wanted to challenge myself. Like I think last year when I had talks with the people from UN Studio, I I was just curious how I would fit in. I just wanted to see how I fit in. But in the end of the day, since I'm also very in love with architecture in general, it wasn't that hard to really get a grip. And now I'm working in various projects within UN Studio, from competition entries to various small side quests, but also data-driven stuff I do with UN Studio as well, which I can't talk too much in depth. Yeah, I will definitely like you see all of the visuals that I have. Some of them I want to really build them one to one. Like I really want to have like a machinic stare or this kind of crazy interactive like I want like I think if you go through my website and check out the most of the theory behind my works, I really want to have some sort of prototyping in that regard as well. But yeah, as long as I'm creating, I'm happy. Let's say it that way. Yes, I tried Karma. Karma is quite nice, but for me personally, I'm sticking with Redshift for now. No, thanks for being here, man. Like I really appreciate it. It's been a while, so I'm always happy to be able to teach or show some stuff. And yeah, and Hana, yeah, Karma, I tried it, but for me personally, I don't care about the visuals that much. Now, I know it sounds a little bit weird, but it's super visual heavy things that I do sometimes. But to be honest, what I always try to do is I just want to bring across the message that the work brings. So I I use Blender. I use like Maya for 8 years, or I have not eight, but 6 7 years. I used before Redshift. I used the mental. No, the what was the mantra a lot in Houdini. Then I switched to Karma a tiny bit, but now I'm mostly using Redshift because I don't have to. It's just really fast workflow based. It's really fast to get stuff rendered quickly. But yeah, I think I will go more in depth, in deep with Karma soon. But yeah, let's see. And yeah, I use Touch Designer with the robotic elements like I think on my website, if I can show it real quick. Like here on this work, like it starts like we created almost this like today. Like maybe not with these elements, but and on this project I had like these prototypes, and these were the previous iterations where I had like these panels that moved. And here, as you can see, this is a prototype. This is actually built, and it was like uh, 3 elements of this piece that you see here. I actually built them in 1:5 scale, so this wasn't 1:1 scale even, but it was already 60 to 70 centimeters high. And as you can see, since I also made sure that I calculated a certain kind of structural idea, the whole thing is standing only on these 3 legs. And those are like, I think 0.5 millimeter, or no, 1 millimeter iron thingies. And as you can see, like here, all of this kind of interaction, this here, it's reacting to sound. Yes, yes, I did all of that. And this was reacting, all of these movements that you see, for example, it was reacting to the sound. And that thing, the connection with these motors and the sound and so on, was I did it all in Touch Designer. But the whole design idea, conception, and so on came from Houdini.
Very cool.
But yeah, let's see.
Yeah.
And I think that was
When are you gonna build the big scale version?
yeah. Let's see when I when I get the funding.
Well, thank you so much for this webinar. It was really awesome to get an insight into your workflow and kind of unique works that you make. I'm sure everyone enjoyed it. It sure looked like they did, looking at the chats. Um, and yeah, looking forward to more in the future.
Yeah. Thanks again for your invitation, and also thanks to all the participants today. And yeah, I'm really happy to be able to show some stuff. always, and also interaction with all of design enthusiasts, different architects, designers, artists, whatsoever, like with the creative community. It's always a really exciting event for me personally as well, because the sharing of information and all of that grows both ends of people. And yeah, happy to be here, and hopefully in the near future we might we might link up again and see where it goes.
Definitely. Well, thank you, everybody. Enjoy the rest of your weekend and look out for an email for the recordings later.
Yeah,
Bye
and
for
yeah,
now.
and guys, if you have any questions, feel free to ask me on. You can send a mail. You can reach me out via DM on Instagram. But yeah, also it can be related to the workflow that we did here, or if you have other questions in this direction, just feel free to reach out. I'm not that type of a guy who ignores people, so don't be shy. But
Okay.
yeah, thanks again, and wish you a pleasant weekend, and hope to see you guys soon.
Yeah. Bye.
Bye bye.